Today we're going to integrate arcsine of x with respect to x. So we'll use by parts for that, where the thing to differentiate we'll call arcsine. So the entire thing, just arcsine. And the thing to integrate will just be 1, because this you can think of as 1 multiplied by arcsine. The reason we do that, there's not a nice easy way to integrate arcsine, so we'll try and differentiate it instead and see if that makes it a little easier. So we'll leave the little space there to try and differentiate it. We'll just integrate 1 to give us x for a sec. Now if we go to this left hand side and think that y is equal to arcsine of x, what we can say by taking sine of both sides is sine y is equal to x. So now we can differentiate this, find dx dy, which will be cosine of y is dx dy. And now we can find dy dx by reciprocating both sides. So dy dx is equal to 1 over cosine of y. But we don't want this in terms of y, we want it in terms of x. So we'll use this line up here, that sine y is x, to try and find a value for cosine of y instead. So if we square both sides, we'll get sine squared of y is equal to x squared. And now we can use our known trig identity, that sine squared plus cos squared is equal to 1. And by rearranging this, we can try and get something that we can replace then the cosine y with something in terms of x, to make it a little bit nicer, keep it in terms of x instead of y. So what we have is now then the x squared plus cosine y squared is equal to 1. So cosine squared y is equal to 1 minus x squared. Cos of y, therefore, is the square root of 1 minus x squared. So dy dx, we know, is going to be equal to 1 minus x squared to the power of minus 1 on 2. So we can fill this thing in on the right hand side. It's going to go just over here. So what we have is that u dash is 1 minus x squared all to the power of minus 1/2. So let's do that by parts now. We'll stick this all together. I, our integral, is going to be equal to u times v. So x arcsine x minus the integral of u dash v. So that's going to be x multiplied by 1 minus x squared to minus 1/2 differentiated with respect to x. So now we need to try and have a go at doing this thing, and we'll actually use a u sub, but because we've already defined it on the right hand side, we can kind of think of it in terms of a y sub. So if we think of this sine y is equal to x, we can replace all the x's with sine y. We already have a nice way to figure out what our differential is going to be. So if we look at this line down here, we have cos y is dx dy. So we can say that dx is going to be equal to cos y dy. So let's just write this on the right hand side. X is sine y. So dx is cosine y dy. Spot on. And we can also use this little fact as well. So our entire bracket is just 1 on cos. Well, 1 on cos y. So let's start plugging everything in and see what comes out the other side. Our integral, we still have the x arcsine x. And now we'll subtract the integral of x, which is sine y, multiplied by dx, which is cosine y dy, and then divided by 1 minus x squared square rooted, so cosine of y. And now these two cosines will cancel off, and what we're left with is the integral of sine with respect to y. So let's compute that. Our x cosine x is still there, x cosine x, x arcsine is still there. And now we'll subtract the integral of sine, which is going to be negative cos. So subtracting a negative makes a positive. Cos of y plus c. So we need our plus c at the end, our constant of integration. And now then, we don't want this in terms of y. We want it in terms of x. So we'll use what we have on the left-hand side, that cos y is equal to 1 minus x squared, all square rooted. So our final answer then, our integral I is equal to x arcsine of x plus 1 minus x squared, all square rooted, and then plus c for our constant of integration.